Hello everyone, and welcome back to the 6th session of low pressure boiler operators training. My name is Ben Weekly, and I herald from the northern part of Minnesota. I have been a boiler operator, low pressure, for about 30 years and have taught boiler classes to many men and women in northern Minnesota over the past 25 years. And I've created this series of YouTube videos to help people out in the industry learn and understand about what boilers are, how they're made and how they operate, and how to operate them safely. And in doing that, hopefully they are able to take their state exams and help them in the process of learning enough material that they can pass their exams and further their career. Like I say, this is session 6, and if you stumbled upon this session 6, I would encourage you, if you are seriously interested in boiler training and boiler operation and the acquiring of knowledge for boilers, that you would touch on or click on the subscribe button at the bottom of your screen. And if you do that, there's no charge to that. But what that will do is it will enable you to go into what's called your subscriptions, and you'll see that at the bottom. It'll go to subscriptions and you'll see my channels listed there. You can go back to the very introduction, and then you can follow all of the various sessions because they are all chronologically in order, and they follow the boiler books that I will recommend to you to purchase, so that when you get to the end of the various sessions that I'm putting together, you will have a great understanding of how boilers operate, and you'll be able to safely operate boilers and hopefully advance yourself as far as being able to pass your state exams or your local exams. So make sure you do that. Let me introduce the books that I'm talking about. If you're just starting out, and some of you that have been following these videos, you're probably tired of hearing me say this, but you never know when people stumble into a YouTube channel. So this particular book here, if you're going to study up on low pressure boilers, it's called Low Pressure Boilers. This is the 4th edition. This is published by American Technical Publishers. Currently there are 5 editions to this book, so this is 1 edition back. I highly recommend that you go to the American Technical Publishers website and purchase the 5th edition, and as you go along, you read chapter 1, you listen to session 1, and so on and so forth. The other thing I would highly recommend is that you purchase this. It's called Low Pressure Boilers Study Guide. It's made by American Technical Publishers. Go to their website and find that and purchase those 2 books. That will be of great assistance to you. It will be an investment in your career. So don't shortchange yourself. Don't just try to listen to my videos and absorb all the knowledge, because I do not cover everything that they cover in a short period of time that I do these videos. If you live in Minnesota and you're just beginning to apply for a license or get licensed, and you want to do that to be a boiler operator, this is the particular book that I would recommend that you purchase. It's called Safe Boiler Operation Fundamentals, Special Engineer's Guide for the state of Minnesota. So that is the particular book. It teaches a little bit on high pressure, and it teaches a lot on low pressure. In Minnesota, with a special engineer's license, beginner's license, it allows you to enter the trade in high pressure boiler systems or low pressure boiler systems, so long as you are under the supervision of a properly licensed operator. Now this here, going back to the textbook, this is the 5th edition textbook right here. This 5th edition is a little different than the 4th edition in that they have dropped the material in here concerning the burning of coal. In low pressure boilers in this country, very, very few burn coal anymore. So get that 5th edition. There's also additional material on hot water boiler systems. So the trend in our industry for low pressure boilers for heating buildings is they are going away, trending away from steam boilers, and they are trending toward hot water boiler systems. And in the last 20 years for heating systems, they're trending away from conventional hot water boiler systems and gravitating towards high efficiency condensing boilers on the hot water boiler systems. I don't want you to think that I'm some type of professional trainer. I'm just another guy, just like all the rest of you, that has operated boilers, and for some reason I was able to get into this boiler training business. I kind of enjoy training guys and ladies that want to do the same type of work that I've done over the years. So it's been my pleasure to do this. Get these books, and if you're reading, I would encourage you to read each chapter as we go through. For instance, if it's chapter 3, you read chapter 3 in the textbook, and then you'd go to the study guide. Don't cheat yourself and go to the study guide and then just go back to the textbook and try to refer and answer questions. You don't learn that way. You're just trying to fill in the blanks. When you get done with your boiler training, I want you to understand boilers, because the boiler operator that understands boilers and has passed his exams, I want that person to be a safe boiler operator. And if you don't understand how they operate, and you've just went through and memorized some questions, you shortchange yourself, and you will not be able to operate boilers as safely as I would like to see it happen. Well, we're going to be talking this session 6, about draft systems. And but before we do, I want to tell you a little story about an unexpected boiler explosion. Well, in some ways it's kind of comical, and in some ways it got pretty serious. For sure, I don't want any of you out there to try to duplicate what happened here. But in my family, at one point in the past, with one of my teenage boys, we had an unexpected boiler explosion. What is a boiler? It's a closed vessel that has water in it and heat applied to it. That's the basics of any boiler. One of my young sons was with his friends, and it was in the fall of the year or late summer, and they were out having a camping trip and enjoying the outdoors. I can just see them telling stories and laughing and having a good time around this big campfire. And after the campfire got big enough, they were able to roast their hot dogs and maybe some marshmallows, that type of thing, and enjoy the outdoors. Well, they had a really nice campfire going. And then somebody, I don't know if it was my son or not, hopefully not, decided that, oh, I got a can of cream corn in the vehicle, and brought that can of cream corn out, and they had nothing to open it with, so they got the idea, let's stick that can of corn down in those hot coals, those red and white and blue hot coals from the fire. And so they did that, and they stood around, and the paper label burned off, and they stood around watching it, and they could start to see the can distort, and they could hear the stretching of the metal. And one of the kids said, "I think we better get back away from this. That thing might blow up." And they did. So they walked back into the darkness of the forest, away from the campfire, and stood back. I don't know how far, quite a ways, because they were getting very concerned that this can might be a danger to them. And it was, because the can suddenly exploded, that can of cream corn. And their campfire was no more. The can exploded and blew the campfire out of the rock ring and extinguished their fire, and all of the trees and bushes in that vicinity were plastered very evenly with cream corn. Fortunately, they had stepped back at a safe distance. They were probably 30 feet back in the woods away from the campfire. Thank goodness for that. But that is the story of the unexpected boiler explosion that occurred with one of my family members. Well, so much for stories. Let's talk about draft systems. Now, draft, every boiler needs draft except, of course, electric boilers. They would be the exception. The draft is the flow of gas or air between 2 points. So a draft in a chimney would be air coming in at the bottom and combining with combustion gases, and it would be flowing through the chimney and going out the top of the chimney or stack. So draft is the flow of gases or air between 2 points. The other thing is, draft systems on boilers regulate the airflow that goes to and out of the burner system. So as air comes into the burner, it's combusted, it's regulated, it makes sure that there's enough there, and it makes sure there isn't too much there. It goes into the furnace, combusts with the gases of combustion, and then it exits the chimney or stack and goes back out to the atmosphere. So the draft system in a boiler system regulates the airflow to and from the burner. Now, as it's trying to do that, there are some obstacles that come naturally with boilers that resist the flow of air or the draft through the boiler. The very boiler shells itself create static resistance. The tubes, the fire and water tubes, create resistance. There can be baffles inside of the boiler system that create resistance. You could have the tube sheets in the front and back wall of the boiler that create resistance. Also, there are turbulators that could be placed in your fire tubes, and there could be dampers in the stack that maybe intentionally create resistance. So the draft system has to be able to overcome all of those various means of resisting the flow of air to and from your burner. Now, atmospheric air, probably since the time you were in 7th grade, you've been told it contains 21% oxygen. And on average, it takes about 15 pounds of air to burn 1 pound of fuel. Now, it's hard to wrap your mind around what is 15 pounds of air, but there is a way of measuring that, and I won't get into that with you, but it takes roughly 15 pounds of air, which is a lot of air, to burn 1 pound of fuel. So just keep that in mind, that without draft in a boiler system, You cannot burn and keep things going efficiently in the boiler without a draft system. It's just not going to work. Years ago, the first draft systems that were out there were called natural draft systems. Natural draft. Well, what's the natural draft? They were created generally by large chimneys. There would be chimneys made out of brick or concrete, and they'd be lined with various materials, and depending on the height of the chimney would depend on how much draft you had. Now, as boilers progressed in the industry, some of the bigger boilers, they just got so large there was no practical way to build a chimney high enough to give enough draft to that particular boiler. So there had to be a way of compensating for that, and so they created boilers that had mechanical draft. But in a natural draft system, the burner combusts the fuel expands and is heated, and as it gets heated and expands, it becomes lighter. As it does that, it rises in the stack, and the cooler atmospheric air takes its place. So that's how a natural draft system works. But natural draft high chimneys, they just have their limits. Some cities today refuse to let you build large stacks like that for obvious reasons, perhaps aesthetic or architectural reasons, or for whatever reason the city just doesn't want those large 100 to 150 foot stacks built. So along comes something called forced draft or mechanical draft. And a forced draft or mechanical draft relies on a fan on the front of the furnace chamber, usually on the front of the boiler itself, and it starts up and it pushes and forces air into the combustion chamber. And as it mixes with the fuel and with the heat, it combusts. It goes through whatever heat exchangers may be in the boiler and exits the boiler through something called the breeching. The breeching is a metal chamber that goes from the top of the boiler over to the stack or chimney. So your forced draft systems rely on a fan that pushes in at the front of the boiler. There may be boilers out there that are very large, and there's a lot of them. Some have combustion chambers in there as large as maybe your living room, very large. And so it takes more than just a forced draft fan to create the draft through all of that large combustion chamber. So they put in what's called an induced draft fan. It pulls or creates vacuum and pulls the products of combustion out of the furnace chamber and exits it through the breeching and on up the stack. If you have a forced draft system and you have an induced draft system, those two fans have to be set and tuned so that they are what they call balanced. They have to be balanced. And on many of these fans, they have what's called a VSD on the motor, a variable speed drive system, which varies the speed of the motor depending on how much draft needs to be created in comparison to how much fuel is being burned. In a large boiler where the chamber is, say, the size of a room, that balanced draft usually balances that chamber so that the combustion chamber has a slight negative pressure, so that if they don't want that chamber to get pressurized and products of combustion or carbon monoxide could get pushed into the boiler room through the cracks and crevices of the boiler itself. So there's a need to be able to determine for the operator what type of draft does he have. Maybe the burner isn't burning correctly, and there is a concern on the operator. Calls a service person, they come in and they measure the draft in the stack. And they measure it with a device called a manometer. And it measures the difference in the pressure in the stack versus the pressure in the boiler room itself. So there's ways to measure that so that the fan, the forced fan and the induced fan, the speed of those and the volume of those can be adjusted so that you get good complete combustion. So you have the forced draft fan, you have the combustion chamber, you go through the product combustion, go through your heat exchanger systems, tubes and so forth. And then as it exits the boiler, it goes through a chamber called the breeching. The breeching itself in many times is insulated. So, and it'll go over to the stack or chimney, and that will exit the building. There is a concern when it comes to stacks and chimneys that the products, the combustion going up those does not get so cool in there that they condense on the outer walls of your chimney or stack. And if it does, it forms this condensate inside of your chimney. The condensate can combine with the various particles of combustion that have accumulated, and it can cause an acidic combination, and that acid can corrode and pit the inside and destroy a metal chimney, and can also ruin the inside of any kind of masonry chimney. Now, we talked about condensing boilers, the high efficiency hot water boilers that are being used. Those stacks or chimneys are made to withstand the condensate, that corrosive condensate. So many times you'll see chimneys like that made of resistant materials to corrosion, high quality stainless steel or perhaps PVC systems, and there has to be some way of capturing or draining that condensate out of that stack and chimney to a safe location so it does not drain back inside of the boiler and eat away the internal components of the boiler. So I guess that's about it for chapter 6 or session 6. Once again, I would recommend that you purchase the books that I spoke to you about. Being a boiler operator and getting a license is a means to making a living, and it's an investment in your future. These books are something that you can refer to. There's much more information in these books than I'm telling you in these sessions. So make sure you get those. Make sure you study the textbook, then do the study guide for each session. Do that before each session that you listen to me talk. And this will reinforce your knowledge, and you will learn greatly from it. So thank you very much for tuning in, and we'll see you next time on session 7.